So hi guys, today's question is partition array according to given pivot. So in this question, we are given a zero indexed integer array and also an integer named pivot, and we need to rearrange the array nums in such a way that these conditions are satisfied. So what are these conditions? The first condition is every element less than the pivot should be to the left of the pivot, and every element right of the pivot should be every element greater than the pivot should be to the right of the pivot, and also the element that is equals to the pivot should appear in between these two. So it means that the immediate left of the pivot. So okay, by reading this question, um, I got some idea on how to tackle this. I feel that um, two pointers might be a reliable approach. You might ask me why. Let me tell you. See, whenever we are taken an array, we were given this array and we are given a pivot. Now, after reading an element, like consider this, the first element is 9. We will be checking it with the pivot, comparing with the pivot. And we feel that, okay, 9 is less than 10. So it should be to the left of pivot. And one more thing, we don't know the index of pivot. So you might ask me, hey Pranav, what we gonna do? How we gonna solve this? Since we don't know the index. And if you say that we need to use a two-pointer approach for this, what are the two pointers tracking? Okay, let me tell you. We are using two-pointer approach. Okay, and if we're using two-pointer approach, you might ask me, what does each pointer track? I can say, so let us consider that we are taking 2 pointers, and left, which is equals to 0, and int right. Okay, there is a reason why I haven't initialized this. I'll tell you in a minute. See, left pointer is to track all the elements that are less than pivot, and right pointer is to track all the elements that are greater than pivot. But you might ask me a question. Hey Pranav, you haven't initialized right pointer, and why? The thing is, I don't know what to initialize right pointer with. And when I think, I got some answer. See, we were given the pivot, and the right pointer should be the immediate index, should be initiated with the immediate index where the pivot appears. So check here. Here we have 10 as the pivot, and check it here. The first occurrence of 10 is at index 0, 1, 2, 3, 4. So pivot will be 4, and then the right initiation should be 5. The element to the right of pivot should be 5. So in order to initiate right, we need to know the index of pivot. So it will be the first occurrence of the target element or the pivot element in the index, in the array. The index, let us figure this out. We'll be running a for loop for int I is equals to 0, I less than nums dot length, and then I plus plus. And now if nums of I equals pivot, then right is equals to I. So what does this loop does? It actually initiates the right pointer value, and after initiating this, we're gonna break the loop. Yeah, because consider two cases. See this: if pivot is initiated here, there will be an issue. We can't work with the array, because if pivot is initiated here, if we want to place another element, It will be the last index and we can't change it. So I'm not initiating it here. It will be the first occurrence. Now, since we have got both the pointers, now I think it's the best time for us. Maybe I think it's not a better idea to do this in place, but let me try. So now we take the array and we iterate over it. On the left is 0 and the right is there. For int I is equals 0, I less than nums dot length. But there will be an issue. If I use a loop like this, and if I'm modifying the same array, what happens is I'm modifying the array in place and also I'm accessing the indexes. So whenever I change the array, indexes might get changed. So it might cause some issues, but let me try. Now, if nums of I is greater than pivot, what happens if nums of I is greater than pivot? What we're gonna do is we're gonna swap nums of Y int temp is equals to right, nums of right. Nums of right is equals to nums of I. Nums of I is equals to temp. Yeah, this is what I'm thinking of. So if the element is greater, we're swapping it. And let's write the code for the element is lesser. If the element is less than pivot, we're gonna choose left, left, but this swapping doesn't make sense to me. Then we're gonna do right plus plus here left plus plus. I'm sorry, here it is right minus minus. So if these were the things to be done, right minus minus left plus plus. And what if nums of I equals pivot? So if this is the case, then int temp is equals to nums of here we're going to take this creates a issue. So what we're gonna do? See, we are actually changing the array in place. I think this code won't work. Let me do one thing. Instead of using this, I feel using an array list will work. We'll first take this into an array list. Array list integer k is equals to new array list. Now, uh, we need a pivot here. Okay, a pivot is needed, and also array list maintains the order in which the elements are inserted to it. So we also have pivot. We have nums. So for int I is equals to int I is equals to 0, I less than nums dot length I plus plus. If nums of I is less than pivot, Then a dot add nums of I. Next, okay. After this, for int I is equals to 0, I less than okay, we're gonna iterate the array again. It's for our own benefit. Nums dot length I plus plus if I'm a bit lazy, so I'm copying it. If nums of I equals to pivot, I'm just adding it, buddy. And then again, going to run the same loop, but in a different manner. If I nums of I is greater than pivot, now all the elements greater will be added in the same order. And then we're going to create a new list. So I mean array, to be frank, int result is equals to new int of nums dot length for int I a for int I in a result of sorry, you can't use this here. Ready? I is equals to 0, I less than nums dot length I plus plus result of I is equals to a dot get I. I think this will work. Return result. Hope this will work. Oh, buddy, made a mistake here. I think it's working. Chalo, let's see if we can submit this. Oops, the question is done. Wow. Okay, this can be described as one of the slowest possible ways that we can do. And now the time complexity is big of n only, since we are using a single for loop each time. But let's check if there is any better way to do this. That's it, buddies.